Hey guys, and welcome back. So at the moment, we've got our two different deployment controllers with two different versions of our app running side by side. But what we haven't done so far is exposed our application to the outside world. So we can do that with a service controller and use the service controller to kind of integrate with our deployment controllers here through the use of selectors to help direct our users or route our users to the appropriate version of our application. So let's go ahead and take a look at the service controller, and we'll take a look at how to use that to point users over to our different versions of our services. So here is our conceptual documentation for the service here. And basically what this service controller is going to be able to do is create a load balancer in Amazon Web Services. And that load balancer will automatically be configured by the service controller to point to our application. So all the traffic will be correctly forwarded thanks to this service controller. And the way that that happens is through the use of something known as the selector. You probably saw the selector over in our replica set and deployment configuration files right here. So the match labels here is basically determining which labels, which pod labels the replica set is going to be controlling. And so that's kind of how Kubernetes is doing its selection. It's basically looking for any pods that have the label of app equal to Trevor Web App v2 or just v1. So the service controller kind of follows the same type of approach here, where it has a selector. You plug in the tags of your, or I should say labels of your pods that you want it to target, and then the service controller automatically calls out to the AWS APIs on your behalf and then routes traffic from the outside world into these different deployments. So let's give that a try. So I'm going to create a new file here, and we'll just save it as service 01. And we'll go ahead and just copy this configuration from the documentation, and we'll just bring that into our file here. So what we want to do is just, let's actually do a Control-KM and do YAML. And I accidentally saved that as a PS1, so we'll do Control-Shift-S and change that to a YML extension. And then what we want to do here is basically set up our service name. So this would be like Trevor Web App. And then for our selector here, this is where we need to make sure that we put in the appropriate pod labels to determine which version of our application we want to point to. So let's go back to our deployment 01 file here, and then we'll grab the Trevor Web App label from there, and we'll plug that in for the selector. So any pods that have the app label with a value of Trevor Web App will be targeted by this service01.yaml. And I'll show you a way that we can actually determine and confirm that we are actually accessing the correct version using the Nginx headers that they provide by default. Now down here we've got our ports that we're exposing to the outside world, and we also have the ability to specify the internal target port. So our internal target port for our pods is going to be port 80, because if you take a look at our container port here, that is the port that Nginx is listening on. So that's what we want to forward traffic from the outside load balancer into. So we're going to take the target port and make sure it's 80, because that's how it's going to target our pods. And then on the outside, on the load balancer itself, we could specify a different port if we wanted to, but I'm just going to go ahead and leave it as 80 as well, because we don't have any other applications that could be running and doing any kind of conflicts, port conflicts with this application. So let's go ahead and just do a kubectl apply on this file. So we'll do kubectl apply -- file name service01.yaml. And that will go ahead and create our service controller. And the service controller, as I mentioned, is going to go out and create a load balancer. And I actually forgot to add in the type of load balancer in here, so that's not quite the correct configuration. I'm actually going to do a kubectl delete on that. So let's do delete file name service01.yaml. And then back here in the documentation, what I'm actually looking for is the load balancer example. Let's search for type load balancer, and this is actually what we're after right here. So we don't need to specify a cluster IP. In fact, I don't think Amazon Web Services supports that. I could be wrong, but we don't need to statically specify a cluster IP. We can just plug in type of load balancer, and the service controller will handle everything else for us. So let's just bring that type into our spec here, and we'll make sure it's at the right level. So it should be at the same level as the selector. So we'll go ahead and just make sure our indentation's fixed there. And I think that looks good. So we've got type load balancer, selector, and then ports. All right, so let's save that, and then we'll go ahead and deploy that down here. We'll hit up arrow a couple of times, do kubectl apply on service 01.yaml, and sure enough, our service has been created. So let's just do a kubectl get all on the current namespace and just ensure that the service was actually created. And then we'll go ahead and do a describe on it. Let's grab the service name to our clipboard. We'll do a kubectl and then describe on that service just to get a little bit more detail about it. And so sure enough, it is going to create a load balancer. And in fact, it already provisioned a load balancer DNS name. Now, by default, the AWS load balancer is going to be a classic load balancer, and that's kind of a legacy resource in Amazon Web Services. There are ways that you can create a layer 4 network load balancer as well, and you can even also set up an application load balancer, which runs at layer 7 as well. But for the time being, we'll just go ahead and stick with the classic load balancer that's being created here. So after this load balancer is created, we should be able to hit this public endpoint and access the application. Something else that's nice about the service controller is that it actually handles setting up the security group ingress rules for us as well on the load balancer. So we don't have to explicitly go out and set up the security group rules to allow inbound access to the application port. Because it knows that we want inbound access on port 80, it just automatically configures the security group rule for us. Over here in the EC2 console, we'll go down to load balancers, and we should see that we have a load balancer created. I'm just going to sort by the creation date here and look for the newest one. That would be this one right down here. And as you can see, it's a classic load balancer, and it is forwarding port 80 on the outside to node port 31962 TCP on the inside. And that's basically how the service controller works here. So you'll see that it actually creates a node port here, even though we didn't explicitly ask for a node port. And so it provisioned node port 31962, and it's going to forward traffic on the load balancer on port 80 to all of our nodes, all of our worker nodes on port 31962. So that's kind of how it does the load balancer, the classic load balancer configuration. And then if we drill into our source security group here as well, this should show us where our inbound access rules are. And as you can see right down here at the bottom, it did actually create us an HTTP inbound rule on port 80 from the world. So we didn't have to go out and set that up ourselves. The service controller just automatically handled that for us. So now what we can do to test out our application is to grab the DNS name of the load balancer. So we'll just come back over here, or we could grab it from our kubectl output here. And then we'll just go ahead and use PowerShell here to do invoke web request -URI, and then we'll paste in the DNS name. And I need to make sure I prefix that with HTTP. And then I'll assign the result to a variable. And it looks like that worked okay. We didn't get any exceptions. So let's do result. And sure enough, you can see that this is the object that gets emitted from the call to invoke web request. Now, one of the nice things about Nginx is that it does by default have a header on it called the server header, and it does tell you what version of Nginx you're running. So you can see we're running version 1.19.0 right here. You could also drill into the headers property on the result, so result.headers, and then you could grab the server header, and that'll spit back the version of Nginx for you. So that's one nice way that you can kind of validate that it's working correctly. Something else that we can do to validate that it's working correctly is to actually look at the pod logs. So let's do a kubectl get all again, and just grab one of the pod IDs from our v1 of our application here. So let's see. So how about we grab this one right here, and then we'll do a kubectl logs dash dash follow, and then we'll paste in our pod here. And then what we can do is to just monitor the logs here to see if our application is being hit. So what I'm going to do is just leave that open right there, and then I'm going to grab the DNS name for our service controller here, and make sure I grab the OM at the end there because it's line wrapping. And then what we're going to do is go into Firefox over here in my browser, and we are going to just hit the service from Firefox here and see if we can get our logs to update. And so it's going to rotate around the different pods in our service, but if we just refresh this service a few times, see how the logs updated right there? That's basically validating that our browser is actually eventually hitting this particular pod that we're monitoring the logs for. And so if I just keep refreshing, eventually, sure enough, you can see it just hit there right again. So it's rotating through all the pods in our service. But what if we wanted to update it to look at v2 of our service instead? Well, what we can do is to update our service controller. Remember, we're using those selectors to determine which pods we want to forward traffic to from the service controller. So over in the service controller, we can just change our selector to Trevor Web App v2 and then redeploy this, and it should reconfigure the load balancer to point to the v2 pods in our application. So let's do a kubectl apply on our service.yaml file. We'll just update that. And then let's try to use the invoke web request command again. So let me hit the up arrow a few times and find that. And if I run this a few times and take a look at the headers, eventually, actually it only took a few seconds here, you can see that the service controller actually cut over to looking at the new version of our pods here. So let me just run this a couple of more times. We'll take a look at result.headers.server. And so every time that I hit one of these containers, it should be rotating around and hitting a different pod on version 1.20. And then I could just change that service controller back to Trevor Web App without the v2 on it. And in just a few seconds here, oops, let me actually do a kubectl apply first. And then once we do a kubectl apply, we should start to see immediately, almost like within milliseconds, it actually cut back to the previous version. So that's how you can use multiple deployments to do kind of a blue-green deployment scenario where you have two different versions of your application running side by side, and then you're able to use the service controller with its selectors to determine which version of your application you want your production traffic to be routed to. I hope this has been informative for you, and I'd like to thank you for viewing.